Okay, grade 12s, I'm really sorry about, just had a bit of a emergency that I needed to take care of in the home front. Okay, in the home front. So unfortunately, that's why I wasn't able to come back as promptly or as immediately as I would have wanted to. So yeah, I'm hoping I'm having my grade 12s in the house. My grade 12s. It is, sorry, let me not call you my grade 12s. You are not mine. You are your school's grade 12s if you are really in grade 12. It's fine, you don't have to see me. I don't want to see you, so let's not see each other. I'm sure you can see black darkness, Lesejo. That's all you should see. Before there is light, there must be darkness, and it must be perpetual. Did you just pull a meme on me? Oh my goodness. Wow, Lesejo. How nice. That is so nice of you. So kind. So generous. But you did what? You did what? Did sell? What's that? But you did sell. Sell what? Sell what? What is Lesejo saying? My gosh, oh my goodness. Oh my goodness, I missed your class. I missed your class. And I was the one that was saying I'm definitely going to make your class. But I missed your class. I am living. Oh, that's good. Oh, that's good for you. I'm happy that you are living. You must live more. Very important to live. The thing is, your living is the one that is saying you are living life. The spelling, I don't know if you are trying to say you are living as in like Leave, meaning you are going away. No, don't. So, I'm just waiting for more of the grade 12s to actually join in. So, guys, today we are actually going to be going into the series part of sequence and series. Because for the past few sessions, we've looked at the sequence part. Okay, we've looked at quadratic sequence, we looked at arithmetic sequence, and we looked at geometric sequence. And there were problems that basically I had encouraged one and all to actually go and do so that they can get the opportunity to sort of get the practice in. All right. Let's come back. That was just initial joking and just obviously me being the way that I am. So if you are in grade 12, then definitely this is the place. And those who do know me in the sessions, I do not show myself there. You want to see me physically. No, you're not gonna see me physically. You are going to see the maths that you came here for. That's what you are here for, right? That's what you are here for. So I'm gonna stick to what you are here for, so that at the end of the day, you can be happy about what you came here for. So we're going to look at series today. Series. Series. Okay. And then I think if there are people that want to or that have specific questions about things that have been done before, then you can always talk about that. But for now, we are going to continue. We are going to start with series. Okay. Because we've done, like I said, we've done quadratic sequence, we've done arithmetic sequence, we've done geometric sequence, and those exercises for that New Mind Action Series are the exercises that you need to make sure that you do. And when you do all of them, it gives you a chance to practice, and I've been preaching this message over and over again. Coming from grade 11, when you do those problems in exercise 1, exercise 2, exercise 3 for the previous topics in sequence and series, it gives you a chance to be able to do things like solve for x, solve for an unknown, use your quadratic equations, apply your algebra, because you want to make sure that those skills that you had attained in grade 11 are still intact. And there's no other way, I personally feel, whereby you can actually get that skill back and fine-tune it than to actually do the exercises in sequences for quadratic sequence, for arithmetic, and for geometric. So please don't be content with just doing a few doing a few of those problems. Try do those problems extensively so that you can get the skill back. Okay, let's say yes, we did do. Oh, you're in grade 11. Okay, we did have a grade 11 session. We did it it's from 9, the grade 11 session, and we just ended shortly after 10:30. So I'll be posting the video of that live session onto the YouTube channel for the grade 11s. And then tomorrow we'll have another session. Okay, let's say we'll have another session tomorrow, same time, 9 p.m. So grade 11 standard, we have a session at 9 p.m. And then my grade 12s, I take them further on. Okay. And apologies if I hurt your feelings earlier on because of the little joking that I made at the beginning. Very, very sorry. Hopefully you can receive my apology warmly and let bygones be bygones. We can be good so that the maths can maths and everything else can be, put aside. But yeah, good night to you. Please spell it right. Please spell that living properly. It's Leaving, living. That's how it is. So a series is created by adding. This is the thing. A series is created by adding terms of a what? Of a sequence. That is a series. A series is created by adding terms of a sequence. Okay. So if we look at a sequence 1, 4, and 9. Thank you, Crystal, for the... Okay, Crystal, I saw your gift there. Thank you so much. And then I can see your comment as well. So if we look at the sequence, you never know. Bitsolam, Kimang. So 149 ... 2a is 1 plus 4 plus 9 plus ... plus 100. Okay, so this is clearly a sequence, this one. But this one is clearly a series. This is grade 12 Mars. 1 plus 4 plus 9. So we are actually creating a what? A series by adding terms of a what? Of a sequence. Okay, I hope you guys see this, guys. All right, now we use the symbol Sn to what? To represent the sum of the first n, we call them the first n terms. Now this n stands for position or number of terms. So we use the symbol Sn to represent the sum of the first n terms of a series. Furthermore, Sn is equal to term 1, which is T1, plus T2 plus T3 plus. Then we can say dot plus. When we speak generally speaking, then it's the nth term. Okay? All right, so I hope you understand this. Sn is equal to T1 plus T2 plus T3 plus T ... I mean, there's an infinite number of terms, but we say plus Tn, which kind of denotes the last term if you want to say it in that fashion. So that's Tn, generally speaking. In a series, 1 plus 4 plus 9 plus, and this obviously being the last term, plus 100. S1, if we look at the sum of the first term, the sum of the first term is equal to term 1. Obviously, guys, the sum of the first term, if you're saying the sum of the first term, you are looking at term 1. Okay? Yeah, which is equal to what? To 1. But the sum of the first two terms, is equal to T1. Okay, Tobile, can you slow down there? You are moving faster. All right. So where did I lose you, Tobile? Tobile. Where did I lose you? All right. I'd love to go with you. And Tobile, I think you are going to be my person in the comment section that I'll be looking out for. Right, okay, no, that's fine, Toby. So, Toby, I will know from you if I'm moving okay or fine. So, you must confirm for me in the comment section, which means you're going to have to pay extreme attention. I know if I'm losing you, then I've lost the entire group in the session. But if I'm with you, the entire group in the session is with us, okay? So, we use the symbol S. N. So this S is a capital letter S, and this N is a subscript to what? We use this symbol Sn to do what? To represent the sum of the first N terms. So Sn just simply means the sum of the first N terms of a series. Sn stands for the sum of the first n terms of a series. Okay? So, if we're looking at Sn, we say Sn is equal to term 1 plus term 2. No problem, that's no problem. Forgiven. Sn is equal to T1 plus T2. Likewise, I apologize. I told you to. I apologize as well. Sn is equal to T1 plus T2 plus T3 plus. Then we have this dot plus Tn. Okay. That's for Sn. Then if we look at a specific series of actual numbers, so in a series 1 plus 4 plus 9 plus plus 100, which is plus 100 is the last term in our series, we can say the following. The sum of the first term is T1, right? I mean, if we are talking about the sum of the first term, we are talking about the sum of that term, the first term, which is what in this series? It's 1, right? The sum of the first term is the first term T1, which is 1. The sum of the first two terms, that means we are looking at T1, which is 1, plus T2, which is 4. So what is 1 plus 4? That is 5. So the sum of the first two terms means T1 plus T2, which is 5. Okay? I'm glad you are with me, Malinga, and I will always be looking at you. Okay? Then the sum of the first three terms means what? It means T1 plus T2 plus T3. Yes, kids, it is, and it will be uploaded onto my YouTube channel after we are done with this. Maths is a game. Sum of the first three terms, T1 plus T2 plus T3. So that means we take the 1, we add the 4, we add the 9. Those are the three terms, and it gives us what? 14. Then if we were to talk about the sum of the first 10 terms, that means we would be adding T1 plus T2 plus T3. Then in between there'd be T4, T5, T6, T7, T8. That's why we have this dot is to accommodate all the other terms all the way up until the last term, which is term 10, because we are talking about the sum of the first 10 terms. Okay, hopefully we get that. So that means 1 plus 4 plus 9 plus dot, all the other numbers in between that feature, plus the last number, which is 100, which will give us a beautiful number of 385 if we were to add even all the other numbers that are in between 9 and 100. the total sum of the first 10 terms would give us 385. All right. So far, I hope we are together. Okay, so I'm waiting for my Malinga brother. Actually giving me Dr. Malinga vibes here. Maybe are you guys related? Are you maybe the son? Hey, it would be cool. Me teaching the son of Dr. Malinga on TikTok. It'd be something else. It would be something else. Yeah, but Malinga, you can confirm for me we are together so that I can proceed. If not, I can go and re-explain what you need me to so that we can be on the same page. Okay, my network is making everybody cry. It's not just the lag. Maybe we're not hearing what's happening. There's this silence. There is a silence that is worrying me. Okay, let me proceed. Grade 12. So arithmetic series is formed by adding terms of an arithmetic sequence. Okay? Yeah. For example, this is a sequence. You can clearly see that because there's no addition or subtraction in between the terms. So this is a sequence. And what type of sequence is it? Okay, I'm sure you can see 2 to 6, 6 to 10. There is a constant difference of 4. So this is an arithmetic type sequence. We can see that from the terms. This here, 2 plus 6 plus 10, this represents a arithmetic series. So this is a series because we can see the addition sign in between the numbers instead of there being a semicolon. Okay, let us proceed. Let us proceed. The formula that we utilize to calculate the sum of the n terms. This is the formula that we use. It is Sn is equal to, right, n over 2, okay, into 2a plus n minus 1, close brackets, multiplied by d, and then you have your brackets for the entire expression inside, all right, from 2a to d, which basically has the multiplication of n over 2 on the outside. Now let's look at what each individual thing means in this expression. So Sn, we have already learned, is the sum of the first n terms. That is generally speaking, the first n terms. If we had 5, then we talk about the sum of the first 5 terms. If we had 7 in the place of n, we talk about the sum of the first 7 terms. So since it's general, we say the sum of the first n terms. Ne? Okay. What is n? N, which is, we see it here and there, n is the number of terms. N stands for the number of terms. Okay. A, what is A? When we did arithmetic sequence, the A stands for the first term. I will, Ngali, don't worry. Everything that I do is posted there, the live sessions. Then D. D is the constant term. This D is the constant term, which means the constant difference. And I just wanted to emphasize that point. It is a particular constant term, but it stands for the constant difference. That's what the D stands for. Okay. Now I want us to look at how do we get this formula? How is this formula formed? we are going to look at the proof of this formula. How is Sn is equal to n over 2 into 2a plus n minus 1 in brackets times d close bracket formed? What is the proof of getting this formula? This is a very important aspect that I am about to cover, and we need to pay attention. This is a proof that we need to know for how to get the sum of the first n terms for a what? For an arithmetic sequence. So first things first, we need to let the first term of an arithmetic sequence. We need to let the first term of an arithmetic sequence be a. Guys, we know most that the first term of an arithmetic sequence is a. But if we are looking at the proof, we let the first term of an arithmetic sequence be a, and the constant difference of that arithmetic series be what? Be d. Okay, so I'm hoping you guys at least you know we let the first term of the arithmetic series be a, and we let the constant difference be what? Be d. Now listen and listen very well. I'm sure you guys know that term 1 of an arithmetic sequence is given by a. Ne? So this is term 1. Ne? Term 2 is given by a plus d. Remember, it's when we take the first term, then we add the constant difference that we get the what? The next term, which if term 1 is a, then it means term 2 is a plus d. Then I'm sure you understand that the next term will be a plus 2d. Ne? Okay. And then you understand that after that we have plus. Then it's dot, 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 plus. The last term, generally speaking, is going to be called Tn. I mean, we could write out the expression. It's that expression that is a plus n minus 1 in brackets times d. But let's write Tn because we know that is the last term. Okay? So generally speaking, we refer to it as Tn. And that's why they say it's where Tn is actually this expression. So we don't write this entire expression, we just write Tn to just make life simple for ourselves. All right? So we know that Tn though is a plus n in brackets minus 1, close brackets with the d multiplied to that. Okay? Let's proceed. So first things first, the proof, we need to let the first term of the arithmetic series be a, the constant difference must be d. Then we know that Sn can be written as the sum of the first n terms, generally speaking, can be written as a plus d in brackets plus a plus 2d in brackets. This represents, obviously, a plus 2d represents term 3 plus, and then we can write the dot 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 plus Tn, generally speaking. Ne? Okay, I think you guys are with me. Now, if we are going to formalize things for ourselves, Sn, you remember I said the first term is a. We add that to the second term, which is a plus d. We add that to the third term, which is a plus 2d, plus the dot 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 plus. Now, very, very importantly, this here are all the previous terms before we get to Tn. If we are looking at a term before this Tn, then it means we have Tn minus, if we subtract the difference, we get Tn minus d. If we subtract the difference again, we get Tn minus 2d. These are sort of like the second last and the third last terms before we get to Tn. I hope you guys understand that. So this is Tn minus d, this is Tn minus 2d. These are the second last and the third last term before the last term. So that's why we have Tn minus 2d and Tn minus d. So let's look at the expression of Sn one more time. We have a, which is the first term, a plus d, which is the second term, a plus 2d, which is the third term. We put the plus, of course. We say dot 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 to indicate that there are other terms, an infinite number in actual fact, and then we write plus. Then for the last two, we write Tn minus 2d, Tn minus d, and Tn. You add plus d here, you get Tn minus d. You add another plus d here, you get Tn. So that's why this makes sense. So this is something you need to know about the expression of Sn. We are together, ne? Now, all you simply do for me now, after you have written this, because this is like where the proof actually starts, after you have written this expression here, you then write the same expression but reversed. You write this same expression but in reverse. Meaning, instead of starting with a, you are going to start with the same expression Sn, but this time round you are going to start with the last term, which is what? Tn. Followed by what? Tn minus d. Followed by what? Tn minus 2d. Plus, then you go back. So you are going back. A plus 2d, which was that. A plus d, which was that. And then a at the end, which was that. So that's why I wrote notes here. You first write the original Sn. Then you write the Sn in reverse. Is step one. What do I mean in reverse? You just simply write Tn first. You follow it with Tn minus d second. You follow it with Tn minus 2d third. And then you follow it with a plus 2d. You follow it with a plus d. And then last but not least, your first term is now the last term. There's that Bible scripture that says the first shall be last and the last shall be first. Don't forget that Bible scripture when you are looking at the proof of Sn. You first write the Sn expression in the way that you know it's supposed to be, and then for your reverse, the first shall be last and the last shall be first. You see that? Okay, I hope you do get that, guys, because it's very key. Step number 2 after that, you then add this expression to this reverse expression. That's why I say add. Are you ready to add? You add in columns like you used to do when you were in grade 6 and grade 7. You say Sn plus Sn. What's Sn plus Sn? It is equal to 2Sn. Do you see that? I hope you see it. Do you see it? Then this a, you add it to Tn. What's a plus Tn? Now a plus Tn. Then you add this a plus d to this Tn minus d. A, you add it to Tn, but the d minus d, what happens to d minus d? It becomes 0. So that's why you are left with what? Another a plus Tn. Let's move on to this one. A plus 2d, you add it to Tn minus 2d. You get a plus Tn. Okay, and so it goes. So basically at the end you get this 2Sn, which is equal to a number of how many a plus Tn's? So many a plus Tn's. People, there are so many a plus Tn's that we get. We get a number of a plus Tn's, and they just repeat each other. Okay. Sinetemba is asking, why do we write it in reverse? That is basically that because we are looking at the proof of proving the Sn formula. Remember, we are trying to basically see how do we get Sn is equal to n over 2 into 2a plus n minus 1d. So this is a given proof. Remember, someone has thought about this. And this is a given proof that we utilize, or this is how we go about proving that Sn is equal to n over 2 into 2a plus n minus 1, the whole thing into d. All right. So we use this development of Sn being T1, T2, T3. We know that T1 is A, T2 is A plus D, T3 is A plus 2D. And the last term, all right, is Tn. Yes or adile? Yes or adile? Definitely is. Okay. So that's why we actually need to know it. We need to know it. All right. So Sn is equal to A plus D plus A plus 2D plus ... plus Tn. Okay. Then, like I said, we just take the very same expression, but we write it this time round in reverse. Okay. So that we can get a sum of the same expression, but just expressed in reverse. So we add Sn to Sn, we get 2Sn. A plus Tn, we get A plus Tn right throughout. Okay, because when you add this and this, you get L plus 2n. You add this with that, you get A plus 2n, D and minus D, they cancel each other, so you're left with A plus 2n. From these two, you also get A plus 2n, because 2D and minus 2D, they cancel each other, you are left with A plus Tn. ... you are left with A plus Tn, A plus Tn, A plus Tn. So all in all, when you added the two expressions, you got 2Sn and then a number of A plus Tn's. So how do we then write this as an equation? This means we have 2Sn, which is equal to a number which we do not know, right? Because remember, I said to you, these A plus Tn's, they are a certain number. So we write this n to indicate we have a number of A plus Tn's. This is to signify a certain number of A plus Tn's that we get. Okay. So I'm just going to recap on this. Please, people, you write Sn, the expression of Sn, until plus Tn at the end. You write the same expression in reverse, starting with the last term, ending with the first term. Then the addition of the two expressions to get Sn plus Sn, which gives you 2Sn. You add everything, you will get A plus Tn right throughout. And then this Sn plus Sn gives you 2Sn, but you know that on the right side you get these numerous number of A plus Tn's, which cannot be counted. So to signify that this is a certain number of A plus Tn's, we write n to indicate this is a number of A plus Tn's in bracket. And then we move on from there. And if you take it one more step, you can see that this 2, which is a coefficient of Sn, we need to divide by it so that we can have Sn as a subject of this equation. So if we divide both sides, this is why I say here divide by 2. So if we divide both sides by 2, what happens? We get Sn is equal to, that means we divide by 2 as well for this. We get Sn is equal to n over 2 multiplied by A plus Tn. Right? Seems like this is nearing the formula that we actually have for the sum of n terms. But do you remember that we said Tn, this Tn is actually equal to A plus brackets n minus 1d. Do you still remember that? The nth term is, the general expression is A plus brackets n minus 1 into d. Well, guys, we can actually take this expression now and go and substitute it in the place of what? Of Tn. Now check the substitution. That means, therefore, we can write Sn is equal to the n over 2, obviously. Then we open the bracket, followed by A, which is the A is there. In the place of Tn, we are going to write a plus brackets n minus 1 brackets d in the place of Tn. So in that entire space of Tn, we are going to write its expression, which is a plus brackets n minus 1 d outside the bracket. Then we close that bracket because it was closed in actual fact. Now, in the brackets, there are like terms. A plus a gives us 2a, which finally gives us Sn is equal to n over 2 into 2a plus brackets n minus 1, close brackets d. And that is the formula. This is the sum of n terms. This is the formula that we use to calculate the sum of n terms for a arithmetic series. Guys, the steps are very simple. You first write Sn, okay, as a plus d. This is term 1, this is term 2, this is term 3. Dot, 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 plus, you write the third last, second last term and Tn itself. Remember, this is Tn, this is Tn minus d, and this will be Tn minus 2d. This is your initial expression, step 1. Step 2, you write this expression of Sn as in reverse. So you still write Sn, but then this side, we are just going to start with the last. The first shall be last and the last shall be first. Tn becomes first now, followed by this, followed by that. There it is, followed by this, followed by that. There it is, and then the first is now last. Ne? Reverse. Next step, add the two Sn's and their column addition. You add. So Sn plus Sn is 2Sn. You add a plus Tn, you get a plus Tn. You add this and this, you get a plus Tn. You add this and this, you get a plus Tn. You add this and this, you get a plus Tn. You get a plus Tn throughout. Okay, that is for 1, 2, 3, 4, 5, 6 columns. But remember, there are these that are in between. So they are innumerable, so we just leave the dot dot dot. We know that would lead to other a plus Tn's that we have not even accounted for. Next step, we get 2Sn. Then this a plus Tn's, which number we do not know, we signify that certain number which is unknown to us as n. This is like a certain number of a plus Tn's. A certain number. That's why I wrote this thing. It signifies a certain number of a plus Tn's, this n. Okay? Then you apply algebraic manipulation. You use the multiplicative inverse. 2 is a coefficient of Sn. So you divide by 2 to make Sn the subject. But what you do on the left, you must do where? On the right. You divide by 2 here as well. You have n over 2 into a plus Tn. Then you conclude. You know that Tn is equal. So you write but. We know that Tn is equal to a plus n minus 1d. So Tn can be replaced with this expression. A plus n minus 1 in brackets times d. So in the place of Tn, we write this a plus n minus 1d in the place of Tn. So a plus will be followed by this a plus this n minus 1 in brackets times this d, and then we close the bracket. But then there are like terms. What's a plus a? It's 2a. Isn't this the formula for the sum of n terms for an arithmetic series? Yes, sir, it is. My people, talk to me. Talk to Papa in the comment section. If it was Mlungisi Nkosi, he would say Bashana. Unfortunately, I don't have those rights and liberties. So talk to Papa. Okay. Alright, Dil, I'm glad you understand. You are, Danko. I'm happy you understand. At least someone understands. It makes me so emotional. Sibani mnikati, thank you, Papa. Aike. It means even you are sorted. Snetemba, I have hope in you. You are my hope. Snetemba, there's hope. In that name, there's even hope in itself. Mpumi. Amen. It's making sense. It's grade 12, prosperity. You are coming with prosperity in the life, prosper. Hopefully you continue to prosper. Maybe if that's your real name, continue to prosper. Prosperity is key. In health and in wealth, it's in health and in wealth. Grade 12, it's grade 12. So one more time, guys, just for those who like you feel you've got it, but you just need that one more time. I'm going to Maths Lead tomorrow, ngeke. What grade are you in? Just for fun? Just for fun is probably saying these things just for fun, because it's probably all about comedy. Okay, remember, guys, the proof of the arithmetic series is we first let the first term of an arithmetic series be A, and the constant difference we know is what? Is D. Nothing in that. So the sum of the n terms would generally be A, which is the first term, plus in brackets A plus D, which is the second term, plus in brackets A plus 2D, which is the third term, plus ... We know we'd say Tn minus 2D plus Tn minus D, and then Tn would be our last one. We know that Tn is equal to this. Just something to note. Where the proof officially starts after stating that the first term is A and the constant difference is D, because that's very important. It starts right here. We write Sn that it is the sum of A plus D, which is the second term, plus A plus 2D, which is the third term, plus there are a myriad of other terms. But the third last, second last, and the last term of this series, 2n minus 2d, 2tn minus d, and plus tn. Let's not forget the pluses, because we are talking about a what here? A series. Ne? Then we write this same sum of n terms in reverse, because that sets up a second equation which we can add so that we can get this 2Sn. That's why we have to set up that same equation, but we write it in reverse. That's all. Then we add. I hope we are vulnering there. So all of a sudden, this Tn is in the first place. This A, which was in the last, is in the first place. It's followed by A plus D, and so it goes. You see these things. This A plus D. Tn now is at first, but it was last. Tn minus D follows. It was second last. Tn minus 2D, which was third last, is now third, and so it goes. A plus 2D follows, A plus D follows, and then A is at the end. Then you add the two what? Equations. What's Sn plus Sn? It's 2Sn. What's A plus Tn? It's A plus Tn. And in actual fact, in each column, you are going to get A plus Tn. That ... obviously will indicate those that are not present, but we know we would get A plus Tn as well. We get A plus Tn for each present column. Then we know that 2Sn is equal to... We have so many A plus Tn's here, so we just use an unknown variable n to signify that there's a certain number of A plus Tn's. Yeah. And then the next step requires us to just use the expression of Tn, which is A plus n minus 1 d, and substitute it in the place of Tn, so that we can get the addition. Or before that, we need to divide by 2. Don't forget that part. We divide both sides by 2 because the coefficient, which is 2 of Sn, we need to get rid of it. We divide by 2 both sides. That leaves us with n over 2. And then we can substitute Tn in the place, A plus n minus 1d in the place of Tn, which leads to the addition of like terms, so that our 2a is there, plus that n minus 1 times d. We close the brackets. That is the formula for the sum of n terms for our arithmetic series. So we know where the formula comes from. It's not something that they thumb sucked out of the blue, but it's something that was, there's a proof for it. We know there's a proof for it. It comes from somewhere. So I'm going to just flow through those examples. Okay, look at this example. It says 3 plus 7 plus 11. We have 3 terms in a series. Plus, and then they say dot dot dot, and then this thing says no, not today, Mpumi, not today, because I'm still starting with series today. There's arithmetic, and then there's geometric, and then the sum to infinity, and then I'll do sigma after that. So we still have a few sessions to go so that we can actually get there. All right, yeah. Appreciate, enjoy the process, and then also I'm sure there's other, obviously, YouTubers or other people that you are consulting in order to actually just make sure you grasp that content for these sigmas and so forth. So by the time I get there, you'll be like, I don't need, I get sigma. It's so easy. I'm even Pumelela ring, because I'm Bumi. I mean, you know me. So this is saying to 30 terms. Right, so we are understanding that we are adding terms here up until the 30th term. All right, up until the 30th term. The last term is the 30th term. The last term is not 30, but there are 30 terms that are being added together. This is what this means. To 30 terms. Okay. So, what do they want? They want us to calculate the sum of the arithmetic series to 30 terms. So we need to calculate the sum of the arithmetic series. They want the sum of this arithmetic series. So how do we go about that? Standard. We calculate, find the value of a, which is the first term. Obviously it's 3. Find the constant difference. Mpumi, this is for series. Remember, we are talking about the sum. When we talk about sum, we are talking about a series. A sequence, remember guys, is not a sum. Alright? Yeah. This is very important. A sequence is a sequence. But the minute you add these pluses and minuses, then you are talking about a sum. But we need to also look at the question. We need to check what the question is saying. In each situation that we go into, we need to first read what the question is saying. So this one is saying calculate the sum of this series, where you have 3 plus 7 plus 11, which forms an arithmetic series, but it says to 30 terms, which means up until the 30th term. So the first term, a is 3, so we need to find a, of course. Then find d. D is equal to t2 minus t1, which is confirmed by t3 minus t2, which is 4. And then we use the formula because we want the sum of the first 30 terms. So we say sum of the first 30 terms. First write the formula and then sum of the first 30 terms, which means n is 30. So this speaks to the fact that n is equal to 30. We substitute in the place of n 30. 30 over 2 brackets 2. Now, the minute we start substituting 2 times 3 in brackets a plus 30 minus 1 in the place of n times in brackets. Remember, you can always put the 4 before the 29, but it doesn't make a difference really. 29 times 4. Then I actually did this manually. 29 times 4 got 116. 2 times 3 got 6. But you guys know that at this stage, even at this stage, where you initially substitute, you can just grab your calculator, guys. You don't have to complicate life. Just grab your calculator. Just put everything in there that you see, and then the calculator will spit out the answer for you. So for instance, I'm just going to do that. We have that 30 over what? Over 2. you have a bracket. And please, all the brackets that you have put in place, make sure that you actually do make sure you put them in. So we have 2, for instance, times the 3, which has that smaller nyana bracket for the 3 itself because it's multiplied to the 2. Ne? Then you say plus. Then there's that smaller nyana bracket where you substitute 30 minus 1 and then you close it. It's just for that 30 minus 1 to be contained. Then on the outside, you are timesing by 4. So you put a bracket to times by 4, or you can just say times 4. You can put multiplication, you can say multiply by 4. And then after that, you do what? You close the bracket. You are closing the bracket from this 2, you are closing the bracket for the entire thing inside there. And then you just say equal. And then you see, the calculator just gives you the answer. And I didn't even have to do all this simplicity. I just write S30 is equal to 1,830. Immediately after I've substituted the 30 with the 3, with the 30, with the 4. I can just substitute and use my calculator. It will give me the answer. So the sum of the first 30 terms is 1,830. In other words, if you add 3 plus 7 plus 11 plus the next number plus the next number up until the 30th term, if you were to add it manually even, you would get 1,830. So the short way to actually get the answer is to use this formula, the sum of the first 30 terms. So do you see why we use this formula in arithmetic series? It's because we are specifically being asked to calculate the sum of the first 30 terms. That's why this formula is relevant for the sum of the first 30 terms, because we are talking about a series and we are being asked to calculate the sum of a arithmetic series. Are you with me? Okay, that's the relevance of the formula. Okay, the relevance is for a series, not a sequence. Now please note this thing here that is being said here. It says when the last term, let's say you are given a series and then they give you the last term. It says when the last term is given, the following formula can be given and used. Okay, this formula, look at this formula. Sn is equal to n over 2, close brackets, a plus l, closed bracket. Remember, people, do you still remember that in your sum, your S of n, Tn is at the end. What is this? Tn can also be referred to as our last doni, our last term. Are you with me, guys? It's at the end. So you can substitute this last term, which we know when we were busy with the formula, which is Tn, which is a plus n minus 1d. We can substitute this last term in the place of Tn. If we have the last term, we can use a shorter formula, which is simply n over 2a plus, what does this L stand for? It stands for our last term in a arithmetic series. Okay, so we can use that if we have the last term. So if you have the last term, we can use this formula to basically calculate the sum of our however many terms, if the last term is there. If they want to find out what is the sum of the entire series and the last term is given to you, you can basically use this formula. But if the last term is not there, then of course we just use this formula. As for instance, this one, we were not given the last term, so we had to use this formula, all right, and get the answer. Let's look at this question, guys. Ronald, thank you so much for the heart there. I see your donkey and the heart. Consider the arithmetic series. Look at this one. Minus 1, minus 3 over 2, minus 2, minus dot, dot, dot. Yes, Oradile, you can. You absolutely can. Good observation. Tn is L. Okay. That's it. Okay. But okay, So consider the arithmetic series, this one. Do you see the arithmetic series? So we are told it is arithmetic, which means there's a first term and a constant difference. The minute they say arithmetic series, we know that there's a first term and a constant difference. They're saying determine the number of terms in this series. Now, please take note, people. They are saying determine the number of terms in this series. Now, for that purpose, we can simply go ahead and use the Tn formula that we know and love. Okay, because we have the last term, which is minus 16. Right? We have the last term, which is minus 16. And we can find what Tn is for this arithmetic series. Okay, we can find the general term of the arithmetic series because it's still in essence a sequence, right? That is arithmetic. So we can say Tn is equal to a plus n minus 1d. A is negative 1. D, on the other hand, we take term 2, we subtract term 1. Minus 3 over 2 minus half. Remember, minus 3 over 2 minus half. Do you see that? Sorry, minus 1. I'm saying minus half. Minus 3 over 2 minus 1. But a negative times a negative will give me a positive 1. So it's minus 3 over 2 plus 1, which gives me a negative half. There it is, negative half. Okay, so that's my constant difference. Then I go and substitute in my formula so I can find what? Tn. After I find Tn, okay, let me go and repeat. Sbanim Nigati is asking what's happening here. The question is saying consider the arithmetic series minus negative 1, negative 3 over 2, negative 2, minus ... negative 13. Negative 16. They are saying determine the number of terms in this series. Now, some of you would have wanted to use the sum series, right, to determine the number of terms immediately. But could we do that? We can't, because, for instance, we don't know what the sum of the sequence is, right? Of the series is. Okay, we don't know what the sum of this series is. And on top of that, we don't even know how many terms are in this series. So we wouldn't be able to determine the number of terms in this series because we don't have the sum. If we knew what the sum of this series is, then we could actually say Sn is equal to that number and then solve for n. But in order to determine the number of terms in this series, we are going to have to resort to using Tn. Why? Because even though this is a series, it's still actually formed from a arithmetic sequence, right? So therefore Tn can be used. So we can find Tn for this arithmetic series. How? We find a, what is a? It's negative 1. We find the value of d, which is term 2 minus term 1. What's minus 3 minus 1? Or minus 3 minus 1? It will be negative 3 over 2 plus 1, because a negative times a negative should give you a positive 1. Then minus 3 over 2 plus 1 should give you a negative half. So that number there is a negative half. So it's my constant difference. So a is negative 1 and d is a negative half. Then we go to our nth term. Tn is equal to, in the place of a, substitute negative 1 plus. Remember, this negative half can be written just before the bracket. Negative half, then we distribute that negative half. Remember? We distribute the negative half. We distribute the negative half. Okay, look, hurry up. Hey, we've detected inactivity during your current live. Complete the verification to continue your current live. They like asking me that question nowadays, verification, and before I know it, they close the live, eh? Alright, anyways, Tn is equal to, like I said, then you take the negative half n, this is grade 12, you take the negative half n, you distribute it. You distribute the negative half n to positive n, you get negative half. You take the negative half, you distribute it to negative 1, you get a positive half. And then you make negative half n, you write it as your first term, and then you add the like terms. Minus 1 plus half, you take your calculator to give you a negative half. So this is Tn. Tn is equal to negative half n, negative half. You now have what the general term of this series is. It is Tn is equal to negative half n minus a half. You know what the last term is for this general term. So you can take Tn and equate it to what? To negative 16. Take Tn and equate it to negative 16. So this is Tn is negative half n minus half. I got it here. You equate it to negative 16, which is the last term of the sequence, of the series, sorry, and then you solve for n. Take negative half over to the other side, it becomes plus half. Grab your calculator, say negative 16, and then you add what? A half. Your calculator is so beautiful. You get negative 31 over 2. Then, since your denominators are both 2, you multiply the left and the right by negative 2. Or you can divide by negative half both sides, which is the same thing. It will give you n, which is positive, and 31, which is positive. Which means how many terms do you actually have in this particular series? It means you have 31 terms. There are 31 terms in the series. Okay? They wanted you to determine the number of terms in the series. So you found how many terms there are. There are 31 terms in the series. And you simply used the nth term, got Tn, then you equated Tn to the very last term of the series so that you can get an indication what is the position of this last term. So if the position of this last term is the 31st position, it means there are how many terms in total in the series? There are 31 terms in the series. Are we together? So that's a question there that you can really, buckle down and answer in an arithmetic series question. This is the type of question where you have to find Tn, then equate Tn to the last term of the series so that you can get the value of n, which gives you the position of that last term, as well as how many terms there are in your series in total. Okay. Yeah. Okay, continuing on. Yeah, we can just endure for a little longer, guys. We will be there just now. 12 is upon us. 8, given the time that we started, we'll end at 12. Calculate the sum of the series. Calculate the sum of the series. So there are two formulas you can use if you ask to calculate the sum of the series. You choose the relevant formula according to what you are given in the particular series. Okay. Obviously, this one is we use it when we have the last term of the series. We can calculate the sum of that series, given that we actually know how many terms there are in that particular series. Or we can calculate that, okay? 2, there's the formula that we already use, which we proved, okay, which is the mother formula for calculating the sum of a number of terms, okay? So remember, in this question we were asked to determine the number of terms in the series. We were able to determine that there are 31 terms in the series. So if we want to calculate the sum of this particular series now, we can do so. Why? Because we know how many terms there are. How did we get the number of terms in the series? We were able to use the general term and then equate it with the last term. After doing so, we know how many terms there are. There are 31, which means we can then use the formula S of n is equal to n over 2a plus L, because we have the last term and we also know how many terms there are in the series. So we say Sn is equal to, so S31, if we're using this formula, S31 is equal to, in the place of n we substitute 31 over 1 over 2. We use brackets. We follow it with 2. What is the first term? It's -1. So we substitute in the place of a -1, because remember in this formula it's a plus L. Okay, so -1 plus, and then the last term in the series, remember, was -16. So that means we get plus minus 16. And then you actually use your calculator. You grab your calculator, you just punch in everything as you see it represented in your calculator with the brackets that you have put in there in place, and then you should get an answer, which is basically what? S31 is equal to -527 over 7. You're asking me how many marks? I actually don't know, all right, because this is an example in a textbook, okay? But if I was to sort of like maybe give you an indication, let's check. So getting the nth term would be a clean 2 marks. Equating Tn to -16 and then getting n is equal to 31 would be another 2 marks. And then using the formula, substituting and getting the answer would be another 3 marks. So this is a clear 7-mark question, but depending on the examiner may decide to allocate marks in certain places depending on what they feel and think. All right, but I am saying 7 marks because it's clearly a 7-mark question, that one. That would just be a beautiful question to be asked, right? It's got a bit of length, and also there's a bit of things that you need to actually do in order to answer the question. Okay. Yes, the formulas are always given. It's not in the formula sheet. You guys get given formulas all the way through now, right? So that formula is there. And by virtue of the formula being there, they expect you to be able to write that formula out correctly first and foremost, and then be able to substitute the values correctly in the formula. So please, people, don't ever lose marks, because the formula sheets are always given to you as a grade 12 learner. Okay. Yeah. We can determine the number of terms that will add up to a specific value by equating. I repeat, we can determine the number of terms that will add up to a specific value. How? By equating Sn to a given value and solving for n. So let's repeat this. We can determine the number of terms that will add up to a specific value by equating Sn to that given value and solving for n. So what's important is that this value that we're equating to Sn is a value that they got by adding up to that value. Okay. So because this value we got it by adding and getting a certain value through addition, then we can equate it to what? To Sn, because Sn stands for the sum of a number of terms. Okay, and then we can calculate the value of n and find out what? The number of terms that added up to that specific value. Okay, so look at this example. How many terms of the arithmetic sequence 8 plus 13 plus 18 plus ... will add up to 1700. So do you see? This is actually an example that is directly linked to this statement. It says we can determine the number of terms that will add up to a specific value by equating what? Sn to that what? That given value and solving for n. I'm going to show you the different things that they mention here in this question. How many terms of the arithmetic series? So we want to find out how many terms of what? Of an arithmetic series. 8 plus 13 plus 18 plus dot 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 will add up to 1700. So this is the specific value that these terms add up to. Now, what do we need to do with this specific value that these terms add up to? What does it say here? We can determine the number of terms that will add up to a specific value by doing what? By equating Sn to what? To that given value. Kaloku, that given value is gotten by adding up to it. And what does Sn mean? It means the sum of a number of terms. So you can take Sn and equate to that value. Right? So the beginning of how we set up this question is we always gonna say Sn is equal to 1700. What did it say? Will add, how many terms of this arithmetic series will add up to 1700? So there's logic in this thing that we are saying Sn is equal to 1700 because we understand that there's an addition of these numbers up until we get 1700. We get 1700 by adding up a certain number of values which basically have these terms in the series in them. So we say Sn is equal to 1700. But remember, we need to find A is equal to 8, it's the first term. What about D, the constant difference? The constant difference is 13 minus 8, which is equal to 5. Then we can take, we did say Sn is equal to 1700. What is the expression of Sn? This is the expression of Sn. We use this one because we don't have the last term in the arithmetic series. So we use this one, not the one with the L. We use this one, the full one, equal to 1700. Then let's go and substitute. We want n most. So we say n over 2. Then in brackets we have 2. The a, we substitute in the place of a, in brackets, the 8. Plus follows. Brackets follow n minus 1. The brackets close and then we have the d. What is the value of d? We did find the constant difference. We said t2 minus t1, which is 13 minus 8, which is 5. There it is. Are we together? Okay. Then from this stage, it's all algebra, guys. It's all algebraic equations. N over 2 is outside this bracket. It has a denominator that is 2. Fractions, in fact, a denominator is not nice to have. So what we do is we're going to multiply both sides by 2. Multiply by 2 over 1 both sides. Multiply by 2 over 1 both sides. In other words, we multiply by 2. If we multiply by 2 in the numerator, it cancels out this 2. We are left with just n next to this bracket. But if we multiply 1700 by 2, we get 3400. Are you with me? And then we sort out what is in the bracket. 2 times 8 is 16. This 5, remember, I can write it before this n minus 1 and I distribute it. 5 times n, 5n. 5 times negative 1, negative 5. Then I add the like terms. What's 16 minus 5? 16 minus 5 is 11. Then I have the 5n. Remember, I had multiplied by 2 both sides. It cancelled this 2. I'm left with n. And then on the other side, I multiplied the 1,700 by 2, I got 3,400. Then from here, I distribute this n, and I distribute this n to the bracket. I get 5n squared plus 11n. Take the 3,400 over to the other side, I get negative 3,400 is equal to 0. I had initially attempted to factorize this thing, but then I thought to myself, why waste my time and factorize this thing? I'm not in grade 11. I've passed grade 11, and in actual fact, I've learned the quadratic formula. So why not make life easy for myself? But remember, in this quadratic formula, you need to make sure that the subject is n, not x. We are not solving for x, we are solving for n, alright? And remember, the quadratic formula is also provided for you in the formula sheet. Letter of grade 11, we did it already. So we have our next session of grade 11 tomorrow at 9. We always have a 9 p.m. session for the grade 11s. But I will upload the video for the grade 11 session that I did on my YouTube channel called Maths is a Game. And all the previous sessions, grade 11 sessions that I've done, are on that specific channel. You can always check them out and give me your sweet feedback. It's raw and as raw as it can get. There's no editing or anything like that. Just the way as you see me, as you're watching the live video, it's exactly as it is. Raw. Okay. So quadratic formula, guys, you know most. You see, I just substituted using quadratic formula. I don't want to go into the details. Surely people, you know the details. Okay, you take A, you take B, you take C. When it's in standard form, you substitute in the relevant places using your brackets. Please use the brackets. In the place of B, remember there's negative B, so it's negative. That's already there in the formula. This coefficient of n is positive, so it's minus times positive 11 in brackets. You follow it with plus minus. In the square root, the B squared means 11 squared in brackets minus 4. Please, people, when you substitute, use brackets. Minus 4 in brackets. A is substituting positive 5. C, you substitute negative 3,400 over what? Over 2 times A is 5. When you are here, you can just use your calculator at this stage already. You don't have to do all of this. You see me, I did step by step. But at this stage, you can just hoy everything into your calculator. Your calculator will give you the answer. You first check when you have this positive alone. Please check with positive alone first. When you've substituted in your calculator, maybe let me do this thing so that I can remind even those ones who have probably forgotten. That is the fraction function. You have minus, you put in brackets minus 11. Do you see that, what I did? I'm going to put plus first. I'm going to do minus later. You take the square root, all right? That is followed by a bracket with 11 squared on the outside, right? Followed by minus, this is 4 brackets times the 5. Okay, I hope there's no grade 11s that I was teaching earlier on in this live, because they're going to be like, oh, this is the formula, and then they'll be like, oh, I'll use it. No, guys, please, you must go and use factorization so far in the problems even that I gave you. Don't try and maneuver now and use this thing. I'm still going to teach you this thing. For now, I need to test your minds and your brains. Okay, there we have it. Then you say equal. You see? My first n value, just from that substitution, is what? There it is. 25. Okay, 25. All right, and this is 25. It's a whole number. It looks good. Then I write it down. N is 25. Okay, or let's go back and go and substitute in the place of that plus. Right, remember there was a plus minus, so that means we need to check when there's a plus, and then we need to check the answer when there's a minus. Our minus answer is negative 136 over 5. If you insist on decimals, it's negative 27,2. You press SD, you get negative 27,2. But we know that we can't accept a negative answer. The number of terms can never be a negative. Like, you can't say there's negative 5 terms in the sequence. I mean, it doesn't exist. Your number of terms will always be a natural number. okay, or whole number if you want to put it that way, 0, 1, 2, 3, and so forth. Does that make sense? Okay, so that means the sum of the first how many 25 terms is the one that's equal to 1700. That's it. That's how we do it. Okay, so the algebra here will be very key. All right, algebra, making sure that we apply the correct algebraic manipulation so that we can get to this standard form. Getting to this standard form is the mission, and actually getting to this standard form is so dependent on how fluent you are in your algebraic manipulation and how good you are with your algebra. So you should be able to give yourself an opportunity to do those exercises in the full breadth and length, and there are so many, but by doing all of them you give yourself a chance to practice and get your algebraic skills up to gear. Okay, I hope you guys are getting converted to this idea of making sure you do all of the exercises. Okay, let's look at this one as well. I think this is the last example, ne? And then the game challenge starts. I'm very sorry that this is dragged out, but I hope you guys get value from having stayed this long. I commend you. I take off my hat for you, to you. Okay, hey, that surname, no Kala, is a very powerful surname, that one. There's someone that I know who's no Kala, who's very good at maths. Very, very good. Consider the arithmetic series -4, -1, +2, plus ... Now this question says, calculate the smallest value of n for which Sn is greater than 300. Utini, wat praat jy? Wat maak jy? Yini le. Sengicabanga ukuthi konke kuhamba kahle. Yini manje le? I repeat. Consider the arithmetic series -4, -1, +2, plus ... Calculate the smallest value of n for which S of n is greater than 300. So they are wanting us to find the smallest value of n. That's the first thing. So they want the value of n, right? For which the sum of the n terms will be greater than 300. So when we add whatever number of terms that we are talking about, the addition of those terms needs to give us a number that is greater, a value that is greater than what? Than 300. They want us to calculate the value of n, which will give us a sum of n terms that is greater than 300. Okay. So listen to this question. This question is saying, consider the arithmetic series. In this arithmetic series, we are given -4, -1, +2, plus, and we are not given the last term. We are not even given what do these terms add up to. But we are asked now to calculate the smallest value of n for which the sum of the n terms will be greater than 300. Not it will be equal to 300. They want us to find the smallest value where the sum of these n terms will be more than 300. Where these values will add up to a value that's more than 300. Okay. So here are the steps, and listen very well.